and tell whether or not it represents y as a function of x. Okay, and so let me show you that. And okay, let me try this again. So let me first have that up, and then I bring that up, and then I go back to this and there. And for some reason it doesn't want to do that, but that's okay. So in any case, if we solve an equation like number 13 for y, we're going to get y squared equals negative x squared plus 4. And when we take the square root of both sides, we get plus or minus the square root of negative x squared plus 4. Okay, when you look at it like that, it becomes clear that this is not a function, because if I plug in a value of x, I'm going to get two values of y. I'm going to get a plus value and a minus value. And functions only have one value of y for every x value. So anytime I see an equation that has y squared or y to an even power, I can be sure that it's not a function, because when I solve for y, I will introduce the plus and minus. So on the test, you're going to be asked a question like, is this a function? And you're going to say yes or no, and then have to explain why. So you have to say, if it's squared, right, then that means that there will be two values of y for every x. Okay. If you look at number 15, since y is not squared, then the same thing isn't true, right? Every time if I solve this, it would be y equals 4 minus x squared. Okay. So now every time I plug in a value of x, how many y's do I get? I just get 1. That's a function. So you could go through these and just see, like this one is a function, 17 is a function, 19 is not a function because it's y squared. 14 is not a function because it's y squared. 16 is not a function because it's y squared. 18 is a function, right? So that's what you're looking for, more or less.